Hi guys, we're going to do a lecture today on the unique properties of water. Unique means it's the only one that does it. Unique, one of a kind. And we're so happy that water has these unique properties, or there would not be life on Earth. And this is not only that. It's a lot of things that water does. If we look back in our very first activity, you had to read that article, and it's responsible for life. You can give us energy. It's got so many things it can do. So we're going to sit there and talk about, just kind of delve into a little bit more. You did yesterday, you did you did Monday, you did the Bill Nye on buoyancy. That's why things can float. Then you did on last Thursday, you did on cohesion and surface tension. Oh, that was Tuesday. That was your lab. So today we're just going to kind of look at all of these together, and just kind of talk about each and every one of them. Once again, on this link, you have a link to your guided notes. Or skeleton notes, and you're going to follow along on those notes and fill in those notes for this PowerPoint. This is your grade for today. So my suggestion is that you have this video up on one side and the worksheet up on the other. So as we go through it, you can go ahead and fill in those notes and make sure you hit the submit button. If you don't hit the submit button, I had some kids on the last assignment. They didn't hit the submit button, and I didn't know they had done the work, because I only look at the submitted work, because I have 100 papers I have to look at. So please make sure after you do your notes that you hit the submit button so it'll get graded. All right, guys, so let's look at our first screen. Unique properties of water. So there is polarity, there's a universal solvent, cohesion, adhesion, capillary action, the high specific heat, density, and buoyancy. And we've already talked about buoyancy. You watched your Bill Nye, and it talks about how things float. Buoyancy, especially with ice, is so important with ice. In your article that you read yesterday, there's not life without that buoyancy. Oh, no, actually, that article you're going to read tomorrow. So I've already given you the answer. Life in water allows fish, when there's ice in the water, the ice will float, which allows the fish to stay, or the other organisms to stay at the bottom, and they can survive because it's still liquid. So without that floating and that buoyancy and density of that solid ice, just like up in the north, organisms can't survive when it turns solid. So we don't want that. So we know that put that up there. We know that the water cycle is fueled by the sun, and our water is constantly changing from a liquid, solid, and a gas, or solid, liquid, and a gas. A solid is the molecules, the atoms are really close together. They still have energy, but not a whole lot of energy. Then it moves into a liquid. You add heat to it, so there's more energy. So the atoms start spreading apart a little bit more. So that's the reason why you get a liquid state. It has a little bit more energy. We put a little bit more energy in the form of heat, and the molecules start moving farther and farther apart, and that's where we get the gas. So those are constantly changing in our water cycle. The water cycle moves it, it changes it, it cleans it. So you can see it always in different forms on our life, on our Earth. Okay, so remember I told you that the atom or the molecule of water looks like the Mickey Mouse ears, and here you can see it side by side. Polarity is like a magnet. So in a magnet, or a battery, but we're going to talk about specifically a magnet, you have a positive end and you have a negative end. So polarity is H2O, okay? So it has the two hydrogen atoms at the top has a positive charge, and the big, huge oxygen atom at the bottom has a negative charge. So what happens is when these water molecules start getting attracted to each other, the positive sides of these ears of one molecule will be attractive to the negative body of another one. So it looks like Mickey Mouse ears. See them? See the hydrogen ears in the mouth and the face. Universal solvent. A solvent is something that dissolves something else. Water, so in this, believe it or not, in this picture, we have people and we have water. Now, if those people stay in that water long enough, the water will start breaking down the body. Now, I'm not just talking about a couple of hours or a couple of days. I mean, it takes a while for the body to start breaking down in water, but it will. So solvent is something that actually breaks it down. Solute is what is being broken down. So in here, we got the water is the solvent. It's like an acid. It can dissolve most substances, including steel, including us, including plastic. It will dissolve it. If it is left long enough in water, it will dissolve. Now, some things going to take a whole lot longer to dissolve than other things. Like if you took, if you ever noticed those Alka-Seltzer tablets, I don't know, maybe not, but if you drop those in there, they start dissolving right away. Like you see the bubbles, and within a minute, they're, it's already gone. It's been dissolved. But if you take a penny, it's got that little green stuff. You've ever seen a penny with the green stuff in it? If you put it in there, if you go back and I think it's like a month, it just depends on how much green stuff in it. But if you come back to it, it will be clean. So it will dissolve that stuff on it. Now, sometimes it might take longer. But if you want to clean your penny really, really quickly, put it in some vinegar. That will definitely clean it. Well, we have cohesion and surface tension, and they work together. Cohesion is when water is attractive to itself. So it's water is attracted to water. So water to water. Now, it's because of these cohesive forces, it creates like an elastic layer at the top. Have you ever eaten something with cheese and you got a layer of cheese at the top? It's kind of, they're all stuck together. That's how water works. It's like, it's not as thick as cheese, obviously, but it has that surface tension and creates kind of a layer at the top. And that's why you can see little bugs walking across the water. And I know I have had a couple of kids have never seen that. Hopefully you YouTubed it, bugs walking on water. It's pretty cool what they can do. Okay, so then you have adhesion and capillary action. While cohesion is when water is attracted to water, adhesion is the opposite, is where water is attracted to other substances. It's like this straw right here. You can see that water is, that liquid is starting to come in there. And then you see these little drops are attracted to that leaf, so it kind of sticks to it. So it's like sticky, it's pulling against it, water can move against the pull of gravity. So next time you put a straw in your soda, watch the straw a little bit above the soda or water or whatever you're drinking. You can see a little bit of that water that is moved above it. And that's that capillary action because it's sticking and it's kind of climbing as it goes. And that's going to get to the point where gravity is stronger and it's going to keep it there. Now, it also has a high specific heat. Now, this is really sciencey here. And you'll definitely delve into this a lot more next year when you go up into Earth and Environmental. But specific heat is how much heat can it hold. So water can hold a lot of heat. It says water has a large heat capacity. It can hold a lot of heat. It takes it a while to heat up, but it can hold a lot. So when we talk about specific heat, it's the amount of heat required to raise the temperature of 1 gram of water 1 degree Celsius. Whew, that's kind of hard to think about. So the really only thing I really want you to know is that it can hold a lot of heat. So water will heat up slow. It takes it a while to heat up, but when it heats up, it will hold that heat for a long time. If you ever go to the beach in the summer, You know, in the mornings when you first get there, the wind is coming from your back, from land, heading to the ocean because that water is cooler. So the heat from the land is going to rush in on top of the ocean. But as the day gets warmer, that water in the ocean is going to start heating up. And now you've got the heat from the ocean. And now the wind switches and you get the wind from the ocean that's coming at towards the land. And that's going to happen especially at night. That's where you get a lot of heat, a lot of wind coming off that ocean at night, and it's blowing back towards the land because it's all that heat, because heat wants to go where it's colder. So that's where you see it. But that ocean water can hold a lot of heat, and that's why we have hurricanes, from that heat being built up, especially around the border. The thing in the middle of the earth, y'all going to think of it. My brain is a blank, but that circle around the middle of the earth, especially around Africa, those where a lot of those hurricanes are built up there, because that water is heated up so much faster. It holds that energy than it is farther up the Atlantic or farther up where we're at. And so that energy is built up, and that's where you get these massive storms from. So changes in temperatures move slower in compounds than they gain or lose heat than they do in liquids. So it takes more energy to change the temperature of water than most substances. But once that temperature starts changing, it holds that heat. All right, density. Density is how close atoms are to each other. In a solid, the atoms are really, really close together. You have more atoms in a solid, the same size solid, than you do the same size liquid and the same size of gas. Just like you have more atoms in a liquid on the same size as you do a same size of gas. So the density is how close those atoms are. So the closer they get, the denser they get. So that means a lot more atoms comes into it. If you took your finger, you can and put it in water, it slides right through it because there's not as many atoms and there's more space, and they kind of move out of the way. But can you do it to the desk that you're sitting at, or the table, or the computer? You can't, because it's a solid. And that those atoms are very closely packed together, and you need to add energy to it in the form of heat or even pressure in order to break those molecules apart. So, but the farther they move apart, the less tense they are, except for water. Water's crazy. Water is unique. So when we talk about solid water, we're talking about ice. And ice, because of those Mickey Mouse ears, has lots of spaces in between them. And that's the reason ice floats, because there's spaces in between those atoms that hold gases. So when they start floating, it has a little bit more buoyancy. So imagine this is a piece of ice here. So it has little air pockets of air here, and it's going to float. It's going to have more buoyancy than, let's say this was a bowling ball. A bowling ball does not have those air pockets in between. The atoms are very closely packed together. They are very dense, and so they're denser than water, and they're going to sink. And there are some things like plastic and other things and rubber that will float, but a lot of times they've put air in there to help it float. We float. We have air in our bodies, our lungs and stuff like that. We actually float because our buoyancy is a little bit higher. So buoyancy is the upward force placed on an object. So right here, you can see here, you've got more force pushing this up. And even though you still have the gravity pushing down here, so you have force from the atmosphere pushing down on it, and you have the force from the water pushing it up. So something like ice, it doesn't take as much force, so it's going to float a little bit higher. Something like a bowling ball, you're going to have the forces right here, and it's going to have more force on top of it because it does not have as much air in it to help push it up, to help this force down here below it. So the force is what causes the objects to float in water. All right, guys. So hopefully you got enough out of this to fill in your blanks. The biggest thing at this level is definitely cohesion and adhesion. Make sure that you know that. And you've observed capillary action, and surface tension is just that tension at the top where that water is linking together. And the other big thing, huge thing, is a universal solvent. Universal means about everything in the universe, it will dissolve. All right, guys, I hope this helped. If you have any questions, please let me know.